In this video, we'll work through examples of calculations for a second order reaction using the linear form of the integrated rate law. In our first example, we'll derive the equation for half-life for a second order reaction. Whenever we're looking at half-life, we set up the relationships of A equals A naught over 2, or A equals 1/2 A naught, and T equals T 1/2. So we'll make those substitutions into the linear form of the second order integrated rate law. So we have 1 over A naught over 2, which I'm going to rewrite right away as 2 over A naught, just flipping that 2, that divided by 2 in the denominator up to the top, because I want to make sure that I don't make any mistakes. And that equals K T 1/2 plus 1 over A naught. We'll subtract 1 over A naught from both sides. So on the left side, we have 2 over A naught minus 1 over A naught equals KT 1/2. So the left side already has a common denominator, and that combines pretty easily. So we have 2 minus 1 is 1. So we end up with 1 over A naught equals KT 1/2. And we're solving for T 1/2. That means that we divide both sides by K. So dividing this side by K, K's will cancel, and then putting a K in the denominator here, and we end up with T 1/2 equals 1 over K times A naught. In this example, we are looking to calculate half-life. We just derived the equation, so I'll write that down. T 1/2 equals 1 over K times A naught. We're given A naught, we're given K, and we can just plug those in. So to ensure that I am careful about the units canceling, I'm going to separate the K term and the A naught term. So I'll be writing it, or I'll be entering the values something like this. So that way I have clear numerator and denominator units for K, and there won't be any chance that I'll forget to cancel units. So T 1/2 equals 1 over K. So the K will start in the denominator, 7.23 times 10 to the negative 3, inverse molarity, inverse minutes. So both of those units will go to the numerator, so it's molarity times minute. And then in the second term, I have 1 over A naught. So that's 1 over 0.4155 molar. Molar will cancel. I'm left with units of minutes in the numerator, and that's what I need. Looking at the sig figs, I have 3 sig figs for K, 4 sig figs for concentration. My T 1/2 will need to have 3 sig figs. When you do the calculation, be very careful about using parentheses in the denominator. Otherwise, the calculator thinks you're trying to do something else and will lead to mistakes. So we have 1 divided by parentheses 7.23 times 10 to the negative 3 times 0.4155 close parentheses equals, and we get 333 minutes. In the next example, we'll start by defining our terms, and then we'll rearrange the integrated form of the rate law as we need to. So the question asks to calculate the concentration of A. So we're trying to calculate A after some molarity of A, that this is the initial molarity, reacts for a time of 5 minutes. And we're given the rate constant. Starting with the linear form, just the regular linear form of the equation, we have 1 over A equals KT, positive KT by the way, plus 1 over A naught. We're trying to solve for A, and in this example, I would recommend solving for 1 over A, which is how the equation is already set up, and then take the inverse when you're all done with that calculation. So we have 1 over A equals K, which is 2.05 inverse molarity inverse minutes, so those will go in the denominator, times T, 5 minutes, 5.00. Our time units will cancel, and with this quantity, KT, we're left with inverse molarity, and that is what we need because our 1 over A naught will also have inverse molarity. That part will be 1 over 0.0986 molar. Looking at the sig figs, we have 3 sig figs for K, 3 sig figs for time. That quantity KT will give us 3 sig figs, and the quantity 1 over A naught will also give us 3 sig figs. And we'll see what that looks like in terms of decimal places and how we need to report our final answer. So I'm going to go ahead and do the intermediate calculations. 2.05 times 5 gives 10.25 or 10.2 because we need to round to even. That's one of those little tricky ones. Inverse molarity. So our 3 sig figs turns out to only be 1 decimal place. This is why we need to be careful about this. And the second quantity is 1 divided by 0.0986. Also to 3 sig figs gives us 10.1 inverse molarity. Turns out that one is also 1 decimal place. So when we add them, we end up with 20.3 inverse molarity, and that's 1 decimal place, which equals 3 sig figs. Now we're not done yet. We need to take the inverse of that, but I do want to show you how the math works out. Let me start with what I have at this point. I have 1 over A equals 20.3 inverse molar. If I cross multiply, I end up with 1 equals A times 20.3. I'm solving for A, so I need to divide both sides by 20.3, and I end up with 1 divided by 20.3 inverse molarity equals A. So when you take the inverse of the number at the end, you just take 1 divided by the number that we got, which was 20.3. This is 3 sig figs. So our value needs to be reported to 3 sig figs. Doing the math, 1 divided by 20.3 gives us 0.0493, and the units are molar. In this example, defining our terms, the question asks how many minutes. So we're solving for time. Does it take for the concentration of A to decrease from its initial molarity, which is 0.035, to some other molarity, which is 0.010. And we're given K. Starting with the regular form of the second order rate law, 1 over A equals KT plus 1 over A naught. We're solving for T, so we first need to get the KT term by itself, and then we can divide by K. In order to do that, we need to subtract the 1 over A naught from each side. So we have 1 over A minus 1 over A naught equals KT. And then if we divide both sides by K, it looks like kind of a mess, but it will work. And we solve for T. I would prefer to rewrite this. So we have it like this. We have that quantity 1 over A minus 1 over A naught. And then we apply our rate constant as a separate term, so that way there's no mistaking what the units are. Plugging in our values for the first term, the subtraction, we have 1 over A, 0.010 molar, make sure you include the units, minus 1 over A naught, 0.035 molar, times 1 over K. So this begins in the denominator, 6.80 times 10 to the negative 1. The molarity times minutes flips to the numerator. And we can start to sort all of this out. The rate constant has 3 sig figs. Let's start there because that's easy. The subtraction that we have over here, each value has 2 sig figs. So after we take the inverse, after we divide 1 by the 0.010 and 1 divided by 0.035, each of those results will need 2 sig figs, and then we'll see what that looks like so we know how to apply that to the decimal places. So let's just do this individually so we don't make a mistake. 1 divided by 0.010 is 100, and we need that to 2 sig figs. It's like it's a little bit confusing, but we'll just mark where 2 sig figs will be, and that's at the tens place. And then 1 divided by 0.035 gives us 28.5 or 28.6, which we would round to 29. That is also 2 sig figs. And we can see that we need to round this to the tens place because that is the fewest number of places. So let's do the math for the first subtraction term so we can figure out how our 2 sig figs translate into decimal places. So 1 divided by 0.010 gives us 100, and the units are still inverse molarity. The sig figs, though, are 2 sig figs, so that would be right here at the tens place. Taking 1 divided by 0.035 gives us 28.6, but I need 2 sig figs, so that would be 29. Also inverse molarity. And when I do that math, 100 minus 29, I get 71. But the fewest decimal places will be at the tens place, coming from the 100. And so even though it seems a little bit odd, we ended up with only 1 sig fig. And now I'll just rewrite how I had K set up so we can finish the math. 6.80 times 10 to the negative 1. Looking at the sig figs now for this final calculation, We only have 1 sig fig for the 71, 3 sig figs for K. So our final result will only have 1 sig fig. Now we want to make sure that the units are working out. We have an inverse molarity and a molarity. They will cancel, and we're left with units of minutes. So doing the math, 71 divided by 6.80 times 10 to the negative 1. By the way, if you rounded that to 70 already, that's okay. It's not going to change the answer that much. I end up with 104, but I only need 1 sig fig. So when I rewrite this, I get 1 times 10 to the 2 minutes. And our final problem, defining the terms, the concentration of A was measured at some value, so that's our A. After 135 seconds had passed, that's our T. Calculate the initial molarity when the experiment started, and then we're also given K. So in this example, we're solving for A naught. Starting with our regular form of the equation, we have 1 over A equals KT plus 1 over A naught. We'll solve for 1 over A naught, and then we'll take the inverse. In order to get that, we just have to subtract KT. So we have 1 over A minus KT equals 1 over A naught. We just have to make sure that when we're done with the calculation, we remember to take the inverse, because once we get this first value, we're not done yet. So 1 over A naught equals 1 over A, which is 0.0218 molar, minus KT. K is 8.1 times 10 to the negative 2 inverse molar inverse seconds. So those will go at the bottom. Times time, 135 seconds. Seconds will cancel. I'm left with units of inverse molarity, and that's what I need to align with the other units. Looking at the sig figs, I have 3 sig figs here, so I'll end up with 3 sig figs. Over here, with the KT term, I have 2 sig figs and 3 sig figs, so that term needs to get rounded to 2 sig figs. So we're just going to go ahead and keep track of these separately. So the first calculation is 1 divided by 0.0218. Reporting that to 3 sig figs gives me 45.9. So 45.9 inverse molar minus 8.1 times 10 to the negative 2 times 135. This one only needs to be at 2 sig figs. That would be 11 inverse molar. And now when I look at the decimal places, I have 1 decimal place. I need to look at the fewest number, and I have the ones place. So my final answer here will be rounded to the ones place. So I have 45.9 minus 11 gives me 34.9 or 35 inverse molar. And this is to the ones place. Now when I take the inverse, A naught equals 1 divided by 35 inverse molar. So I can actually just flip that molarity to the top. This should be 2 sig figs. And when I do that math, 1 divided by 35, 0.029 molar is the original concentration.